You're looking at the hidden code behind the Cambridge high-tier exams right now. We're completely forgetting generic study advice today and just bypassing all the fluff. We're jacking directly into the mark scheme matrix for Physics 0625. Seriously, if you want to stop bleeding easy marks on motion questions, you need to start seeing the exam exactly the way the examiner does.
So imagine an exam question asks you to describe the motion of an object. A student writes, speed increases by 5. It sounds logical, right? The data clearly goes up by 5. Yet this answer scores an agonizing 0, literally 0 marks. Why? Well, because it completely ignores the strict, unwritten rules that examiners use to separate the top bands from everyone else.
Here's the glitch in the matrix. Ordinary revision, it just fails. It fails completely because, students spend all their time trying to understand the underlying physics, but they completely miss the examiner's hidden coding for grade boundaries. Knowing the science simply isn't enough. Not anymore if you don't know how to speak the examiner's highly specific language.
Let's look at how this builds into some of the most painful mistakes you can make on paper. These are the common traps that will absolutely tank an otherwise perfect exam. Missing your units, rounding your numbers way too early in a multi-step calculation, offering vague explanations instead of, precise scientific reasoning, flipping your graph axes, giving weak practical improvements, identifying the wrong variables, or making broad conclusions that just aren't directly supported by the data table. Honestly, these are silent killers.
Okay, so let's dive into this. To actually beat the matrix, we need to lock in our first quick win before we even touch any lab apparatus. These right here are your Cambridge non-negotiables. Average speed is simply the ratio of total distance traveled to the total time taken. And acceleration is the change of velocity divided by the time taken for that change. Or, mathematically, A equals delta V over delta T. You got to burn these exact equations into your memory right now.
Now let's apply those equations to the classic ticker tape timer practical. And actually, scratch the usual way you think about this. Stop looking at the ticker tape experiment as some boring lab chore. This is actually a highly strategic tool designed specifically by examiners to extract practical method marks from you. Here's the setup. You pull a 1 meter length of tape through the timer. Then, and this is absolutely critical, you cut the tape into 10 tick lengths. That means you make the physical cut on the 11th dot. Finally, you arrange these successive strips vertically, side by side.
Listen, if you only take away one single thing from this section of the explainer, let it be these numbers. The ticker tape timer makes a dot at very specific time intervals. One single tick, so the space between two dots, equals exactly 1/50th of a second. Therefore, a 10-tick space is 10 times that, which gives us exactly 1/5 of a second. Knowing this exact fraction of a second, that is the secret key to unlocking every single calculation mark in this practical.
And this setup brilliantly illustrates acceleration. By constructing these tape charts side by side, where the horizontal axis is time, measured in those consistent 10-tick intervals we just talked about, the vertical height then represents distance. Because the time interval for every single strip is identical, exactly 1/5 of a second, the increasing height of these strips directly proves increasing distance over the exact same amount of time. It's visual proof that the trolley is moving faster and faster.
But hold on a second. Before you calculate anything, let's secure the easiest marks on the entire paper. When Cambridge asks for a safety precaution for this setup, please do not write something vague like "be careful." No way. Write this exact phrase. Ensure the trolley does not fall from the end of the runway as it could cause injury to legs or feet. It's highly specific, it's physically relevant, and it is instantly rewarded by the mark scheme.
All right, before we go any further, I've got a crucial question for you. What is the single examiner clue that turns a basic 2-mark descriptive answer into a 4-mark analytical masterclass? In just a moment, I'm going to reveal the ultimate examiner's secret that will change how you answer motion questions forever. But I'm warning you, clicking away from this explainer now means missing the exact framework that pretty much guarantees those top bands. You need to see this.
Okay, here's that secret. This is the core 4-step matrix framework. When you're asked to analyze motion, you can't just state a fact and hope for the best. You have to follow this exact chain. First, state the concept. Second, pull raw evidence or data straight from the source page or table. Third, apply your scientific reasoning. And fourth, wrap the whole shebang in precise examiner wording. You literally have to force the examiner to give you the marks by proving your physics concept with raw, hard data.
Let's escalate the stakes a bit and put that framework to the test with some real data. Imagine an actual data table derived from a ticker tape chart. Time interval 1 shows 2.0 centimeters,
time interval 2 is 4.0 centimeters, and time interval 3 is 6.0 centimeters. Obviously, the tape lengths are clearly getting longer, right?
Well, this is where watching becomes doing. I want you to pause this explainer right now. Seriously, grab a piece of paper, look at the data we just reviewed, and use the formula A equals delta V over delta T to calculate the acceleration yourself. Remember what we said earlier about the time interval for one 10-tick strip? Treat this like a high-stakes exam simulation. Go ahead, pause now and predict the answer.
All right, welcome back. So, the final calculated number is 100 centimeters per second squared. Now, the crucial point here is this. If you just wrote 100, or even 100 centimeters per second, you lose. Failing to include the squared time units here results in an instant, agonizing mark penalty. The unit is literally just as important as the number itself. Acceleration is the change in velocity over time, which means time is squared in the denominator. Don't forget it.
Notice the massive gap here between just understanding the physics and actually getting the marks. Take a look at a flawed answer. The tape gets longer, so it's moving faster. I mean, the physics is technically true, but the wording is just fatally vague. Now compare that to the top-band matrix answer. Tape length increases per 10-tick interval, 1/5 of a second, proving acceleration as distance covered per unit time increases. See the difference? It names a specific interval, it includes the fraction of a second, and it directly connects distance over time to the definition of acceleration. That is a bulletproof answer. And hey, if you don't believe me, just listen to the people actually grading your papers. This is a direct quote straight from the examiner's report. Candidates frequently lost marks by providing conclusions unsupported by data and omitting critical units in velocity change calculations. Ouch. This brutal feedback perfectly validates our four-step framework. Using top-band wording isn't just a suggestion, it's completely non-negotiable if you want those highest grades.
So before you ever move on to the next page of your exam, you need to run your answers through this rapid-fire final checklist. You've got to scan your paper like a Cambridge examiner would. Ask yourself, did you substitute values with their correct units? Did you actually fulfill the specific command word? Did you use exam-safe, precise wording? Are your significant figures appropriate for the data given? And finally, did you cite exact numerical evidence from the source page? If you can confidently check all 5 of those boxes, your marks are secure.
All right, so you've survived the ticker tape practical. You know how to extract the timing, you can calculate the acceleration, and you can construct a top-band answer. But listen to me, perfectly calculating acceleration is completely useless if you misread the hidden instructions in the question itself. There are fatal traps buried inside Cambridge command words that decide your entire mark band before you even pick up your pen. Understanding this deeper code in the command words makes the next explainer absolutely mandatory to watch right now.
Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCE to excel in your Cambridge examinations. Seriously, click on the next explainer on your screen right now to decode those command word traps. Because if you don't know the difference between state, describe, and explain, are you really ready to take this paper? I'll see you in the matrix.